Hi there everyone, welcome back to our vector calculus course. In this lesson, we're going to talk about something really useful, how to take derivatives of polynomial functions. Now, in the last chapter, we learned how to find the slope of a curve by going through that limit process. It was fine, but honestly, it's not something you want to repeat every time. So now we're going to learn how to do it faster by using shortcut rules. All right, let's get into it. We've got a few basic rules that make this easy. First, the constant rule. If a function is just a constant number, like 5 or -2, then its derivative is 0. Because a constant doesn't change, so its rate of change is 0. Next is the power rule. If you have x to the power of n, you bring down the exponent and reduce the exponent by 1. For example, the derivative of x to the power of 4 is 4 times x to the power of 3. Simple, right? We also have the constant multiple rule. If there's a number multiplying the function, like 3 times x to the power of 5, then you just take the derivative of the function and multiply by that number. Then we've got the sum rule and difference rule. If two terms are added or subtracted, just take the derivative of each term separately and keep the sign. Let's go through some examples so this all makes more sense. Example 1. We want to find the derivative of f of x equals x to the power of 4 minus 5, x to the power of 3, plus 3x to the power of -2. All right, let's go term by term. The derivative of x to the fourth is 4x to the third. The derivative of -5x cubed is -15x squared. And the derivative of the 3x to the -2 is -6x to the power of -3. So the final answer is 4x to the 3 minus 15, x squared in minus 6x to the -3. Example 2. Find the equation of the tangent line to f of x equals -x cubed plus 3x squared plus x minus 7 at x equals 2. Okay, first we need the slope, so let's take the derivative. The derivative is -3 x squared plus 6x plus 1. Now by plug in x equals 2, we get -12 plus 12 plus 1. That gives us a slope of 1. Now let's find the y value. Plug x equals 2 into the original function, -8 plus 12 plus 2 minus 7. That's -1. So the point is 2, -1, and the slope is 1. Now let's write the equation using point-slope form. Y plus 1 equals 1 times x minus 2. So the equation of the tangent line is y equals x minus 3. Example 3. We want to find where the function f of x equals -x cubed plus 6x squared plus 9x plus 7 has a horizontal tangent. That means we're looking for where the derivative equals 0. Take the derivative. -3x squared plus 12x plus 9. Set that equal to 0. Let's divide everything by -3 to make it easier. X squared minus 4, x minus 3 equals 0. Now solve with the quadratic formula. X equals 2 plus or minus the square root of 7. So the tangent is horizontal at x equals 2 plus the square root of 7 and x equals 2 minus the square root of 7. Example 4. Here's a fun one. Where does the function f of x equals 2x cubed minus 3x squared minus 30x plus 1 have a tangent with slope 15? Let's find the derivative. 6x squared minus 6x minus 30. Set that equal to 15. So we have 6x squared minus 6x minus 45 equals 0. Divide by 6. X squared minus x minus 7.5 equals 0. Now use the quadratic formula. We get x equals 1 plus or minus the square root of 31 over 2. So the tangent has slope 15 at those two x values. Last one, example 5. A real-world application. A ball is thrown into the air, and its height in meters after t seconds is negative 5 t squared plus 20 t plus 2. How fast is it rising or falling at time t equals 1.5 seconds? Let's take the derivative. H prime of t is negative 20 plus 20. Now plug in 1.5. That gives negative 15 plus 20, which equals 5. So at 1.5 seconds, the ball is rising at 5 meters per second. All right, let's wrap up. We saw how to take derivatives quickly using a few rules. We used the power rule, the constant rule, and we learned how to deal with sums and product. Then we applied those ideas to more challenging examples, like finding tangent lines, critical points, and real-world rates of change. These shortcuts save time, and they're going to be super helpful as we get deeper into calculus. That's it for this lesson. Take a break, and I'll see you in the next one.